Good morning, everyone, and welcome to another beautiful day. Today, our focus question is going to be, how can you change one unit of measurement to another unit of measurement? We're going to be taking a look at that star reference chart that I gave you that you should have still in your binder. You don't need it out right now because you're going to see clips that are going to help you focus in on exactly what you should look for in different situations. But if you'd like to have it out so that you can reference what you're seeing on the screen to what you would see on the reference material, you're welcome to do so. Please make sure that you're taking notes as you do this PowerPoint, but do know that this video will be available to you through the end of the year. All right, units of measurement can be converted within the same measurement system. So for instance, let's focus on converting customary units of measurement. Now we know that that customary is what we use in the United States. Miles, yards, feet, gallons, quarts, pints, cups, tons, and pounds. Because customary is separate from metric. We're going to be working with both of those, but for right now, we're going to focus on customary units of measurement. So when you look on your star reference chart, you'll see, just like the picture on the screen, these conversions for you, that 1 mile equals 1,760 yards, 1 gallon equals 4 quarts, 1 ton equals 2,000 pounds. So we're going to look at how many feet are in 5 yards. If you're not sure of the relationship between feet and yards, refer to the star reference chart. It's listed right there for you. Now, let's use a model to convert feet to yards. The model shows 5 parts to represent the 5 yards. So if you notice, just like we do in class, our total bar is on top, so our total is 5 yards, and then our parts bar is split into 5 pieces. There are 3 feet in 1 yard. 1 yard equals 3 feet, so we've put in 3 feet for every single box. Now, in this case, if you're thinking about the differences between addition, subtraction, multiplication, and division, addition is when you're putting multiple pieces together to create a total. Subtraction, you have a total. You're taking a part away to find the missing part or another part. Multiplication, you have one piece that same equal piece is being repeated multiple times in order to find a total, which would then be the product. And division, you're taking a total and you're splitting it into equal groups. Now, in this case, you have 2 different options because technically you could add 3 plus 3 plus 3 plus 3 plus 3. So let's take a look at what this would look like. So you have one option of 3 plus 3 plus 3 plus 3 plus 3 is going to equal our unknown, forgive me there, our unknown number of feet. That's supposed to be a U, by the way. Our unknown number of feet. Or we know that we have 5 groups and there are 3 feet in each group. So I can also do 5 times 3 would equal our unknown number of feet. Okay, so that's 2 options for you. All right. So just like we said, 3 times 5 would equal 15. So how many feet are in 5 yards? Using an input-output table can also help when converting units of measurement. If we know that 1 yard has 3 feet how many feet are in 5 yards. Input-output tables work with conversions just like regular information. So now we need to figure out the process. What is the process or operation for finding how many feet are equal to 5 yards? Well, in this case, we know that to turn 1 into 3, we can either add 2 or we can multiply by 3. And in this case, because we know, whoops, goodness gracious, this pen is uncooperative, isn't it? We know that 1 yard equals 3 feet. We know that we're not adding here. We're not putting multiple pieces together. We're multiplying. So that means that we are going to be multiplying 1 times 3 to equal 3. So if we have to multiply the yards by 3 to equal the number of feet, we also need to multiply 5 times 3 to equal the number of feet. So just like we said, the process or operation used to find how many feet are equal to 5 yards is multiplication. And just like our previous screen, we found that 5 yards multiplied by 3 feet each is 15 feet total. Tables or models can be used to convert measurements in the same measurement system. So there are 15 feet in 5 yards. How many quarts are equal to 7 pints? Pardon me. If you're not sure of the relationship between quarts and pints, refer to the STAR reference chart. That is going to be your best friend with conversions because it shows you right here, 1 quart equals 2 pints. So if we have 7 pints, 1, 2, 3, 4, 5, 6, 7, then we know that 2 pints are equal to 1 quart. So there's 2 pints equaling 1 quart. There's 2 more pints that equal 1 quart, 2 more pints that equal 1 quart. Now we have this pesky little thing on the end. And there's 2 different ways that you can do this, but let's follow the PowerPoint first because there's 1 pint left over. So you can either write this as 7 pints equals 3 quarts and 1 pint, or for those of you that really like decimals or fractions, it could also equal 3 and 1/2 quarts, or you could also write it as 3 and 5/10 quarts. Okay. But most likely when you're tested, they're going to put it in this format where you have the number of quarts, and if it's unequal, then you're going to have the pints attached to it that way. So how can we use an input-output table to convert these measurements, just like we did before? We need to think about how many pints is equal to 1 quart, and in this case, they flipped it this time. Now we have the 1 quart on this side, because remember, input-output tables, your input always goes on the left, your output always goes to the right. Now in this case, to turn 2 into 1, we have to divide. Because knowing input-output tables, if our number and our input is larger than our output, we're going to have to either divide or subtract. But in conversions, you're either going to be multiplying or dividing. So in this case, if our input is bigger than our output, we're going to have to divide. So 2 divided by 2 equals 1. And then 7 divided by 2 is 3, remainder 1, which in this case we have 3 whole quarts and 1 pint left over. Now, if you remember back to one of the perimeter and area problems that I gave you last week, where you were asked to find the length of side A, if you knew that A and B were congruent and you were given the perimeter and the measurements of the other sides. One of the reasons that I gave you that problem is because of this process right here. That way you can understand how you would split this and turn it into a fraction or a decimal. But again, that's only if you really want to take this to the next step. When you're tested, most likely you're only going to be required to turn it into this format. Tables or models can be used to convert measurements in the same measurement system, just like before. So you have our input-output table or the model. I highly recommend you using the model because, as you can see, this model is a lot more straightforward and visual than our input-output table. All right, let's try one on your own. 3 pounds equals how many ounces? Pause the video for just a moment, and I want you to try this one on your own. All right, hopefully you took the time to pause the video and try and work this one on your own. But let's take a look at what we've got. Now, if I'm looking at my star reference material, I am going to look under the weight and mass category that tells me that 1 pound equals 16 ounces. So let's start with our model. We have a total of 3 pounds. And so my parts bar is going to be split into 3 pieces because each piece is 1 pound. And if I know that 1 pound equals 16 ounces, then I can simply fill in the box for each of these for 16 ounces. I'm going to try and squeeze in the labels here because labels are important. We're not talking paper clips. We're not talking cars or desks or sticky notes. We're talking about pounds and ounces, so make sure you're remembering those labels. And then we could also do our input-output table. So we have, I'm going to try and draw this as best as I can. We have 1 pound equals 16 ounces. Oop. And we need to find how many ounces 3 pounds is. Well, if we know that 1 turning into 16, we're going to have to multiply by 16. That means we need to do the same here. And when we look at this, we can see that that's going to be correct because we have 3 groups with 16 in each group. So I'm going to multiply 16 times 3. 6 times 3 is 18. We carry our tens We leave our ones. 1 times 3 is 3, plus 1 is 4. So that means that our unknown is 48 ounces. So I want you to take just a couple of seconds, pause this video, go back and take a look at the work that you did when you tried this problem on your own. How did you do? Where did you get confused? Is there anything that you need me to clarify? Any questions that you need to jot down that you need to ask me? Take a couple of seconds, pause this video, and review your work to make sure that there's nothing you need to ask me. Okay, let's move on. So, knowing, then they're going to review this as well. So with weight and mass, 1 pound equals 16 ounces. Their model looks exactly like ours. Or pounds, process, ounces. 48 was the correct answer. All right, now this is a challenge. Even though the PowerPoint says work with a partner, I want you to try this one on your own, okay? So I want you to pause this video and take a couple of seconds, even a couple of minutes if you need to, and see if you can figure this one out on your own. Okay, let's take a look. I have 6 inches and I need to know how many feet. Now I know that 1 foot equals 12 inches. But I only have 6 inches. So I'm going to draw this. I'm going to draw my model. Pardon me for coughing. So I have thirds and then 6. So this is 1 inch for this one box. Now, let me see. I'm going to change my pen color here because if I only have 6 inches, but I know that 12 goes in a foot, I'm going to extend my model so that there's thirds and 6 so that I can then see, and I know I'm drawing my total bar below, but still a total bar is a total bar. So this equals 1 foot and so now we have a model of how much we have and how much would be added to equal our total. So let me change back to my red. So if I know that I have 1, 2, 3, 4, 5, 6 pieces out of 1, 2, 3, 4, 5, 6, that makes 12 total. 6 out of 12, I can then reduce this fraction. I know that 6 and 12 are both divisible by 6. Six divided by 6 is 1. 12 divided by 6 is 2. So that means that 6 inches is equal to 1/2 of a foot. So 1/2, or you could write it as 5/10. Okay, because 1/2 is equal to 5/10. Let's take a look at what this would look like as an input-output table. Okay. Okay, had to clear our screen there for a minute. So if we have all right, 3 pieces. We have inches, process, and I'm just going to shorten that to feet. If I know that 12 inches is equal to 1 foot, and I have 6 inches, and I need to know how many feet, I know that I have to divide 12. Whoop, that was not the intention. Ignore that, please. 12 divided by 12 to equal 1. So that means that I need to take 6 and divide it by 12. Now we can do this one of 2 ways. Again, we've already looked at the fraction portion because a fraction is simply division. We've already turned 6 divided by 12 into 1/2 or 5/10. But let's see what it looks like doing the actual long division to get this decimal. So my dividend is 6. I'm dividing it by a divisor of 12. And I know that 12 cannot fit into 6 evenly, so I'm going to go ahead and add my decimal and a 0 to the end. And since our dividend has a decimal, but our divisor does not, I'm just going to simply go ahead and bring my decimal up into my answer. Now, 12 cannot go into 6. 12 times 0 is 0. We bring down the 0 that we added. And 12 fits into 65 times because 12 times 1 is 12. 12 times 2 is 24. Times 3 is 36. Times 4 is 48. And times 5 is 60. If you need to write these factors out when doing long division, please do so. Don't think that you're going to get in trouble for this. This is simply a resource in helping you. If you need it, please do it. So 12 goes into 60 5 times. 12 times 5 is 60. Leaves us with no remainder. So now we have nothing left over, nothing to bring down, so our decimal has terminated. That's what that means when you have a decimal. There's nothing left to bring down. There's no remainder left over. The decimal has terminated, and you are finished dividing. Okay. All right, let's take a look at what they say and see if they did anything a little different or any tricks that we could use. There are 12 inches in 1 foot. Will this be greater than or less than a foot? All right. So once again, just like we did, they did a model with 6 inches as the total and 6 boxes. How many more inches are needed to equal 1 foot? Well, we know that. We need 6 more. So there you go. Now you have 1 foot. 6 inches is part of 1 foot and can be written as the fraction 6 out of 12, which is equivalent to 1/2, which is exactly what we got. And the input-output table. 12 divided by 12 or 12 divided by 12. This is just the reminder that a fraction is simply a division problem. 12 divided by 12. Remember, a fraction is dividing a whole part into parts. Therefore, 12 divided by 12 can also be written as 12 over 12 and is equivalent to 1. 6 divided by 12 can be written as the function 6 over 12, which is equivalent to 1/2. All right, this is your chance to show what you know. Take a couple of seconds, see if you can solve this one. Okay, now let's take a look at what they did. They have 12 feet, 6 inches. So they did 12 feet, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then they add these 6 inches onto the side. And so we know that 1 foot equals 12 inches. So we have 12 times 12 plus that other 6. With our input-output table, 1 foot equals 12 inches. So 12 inches equals 12 feet equals 144 inches. But you have to remember to go back and add in that extra 6 inches, which is how we take the 144 inches in the 12 feet, add in the extra 6 inches to equal 150 inches. Okay, this is a challenge bonus. Pause this and take a couple of seconds to see what you can do. All right, with volume and capacity, we know that if there is a relationship, what relationship can be used to solve this conversion? Because we have gallons to quarts, and then we have quarts to pints. So it looks like we're going to have to be a little tricky with this. Since there is a relationship between pints and quarts, let's start with quarts. We first need to figure out how many gallons are in quarts. So if we have 8 gallons, 1, 2, 3, 4, 5, 6, 7, 8, 4 quarts each, 8 times 4 means that we have 32 quarts. Now we're getting somewhere. Or if you prefer the input-output table, 1 gallon equals 4 quarts, 8 gallons times 4 equals 32. But is this really our final answer? Does this tell us how many pints are in 8 gallons? No, because we're still at quarts. We haven't figured out pints yet. So we're going to have to convert a second time. Now we have 32 quarts equals how many pints? Because we know that 8 gallons equals 32 quarts. Now we can convert this time. So we have 32 quarts, 1, 2, 3, 4, 5, 6, and we're going to continue this pattern until we have that 32 times. And each quart is 2 pints. Or 1 quart, process is multiplying it by 2 equals 2 pints. So therefore, 32 times 2 equals 64. Therefore, this took 2 steps to solve. We had to convert gallons to quarts and then quarts to pints. Models, tables, and the STAR reference chart are the tools you need to succeed when converting measurements. Well, thank you so much for watching, ladies and gentlemen. I appreciate your time, and we will see you next time.